Here's the introduction to double angle formulas, part 1. These are on your gold formula sheet. If you want to take the time to write them down in your notes, you can do so too. They're in the green box. Be careful when you identify the double angle. We've talked a lot about the sine squared of x can be split up as the sine of x times the sine of x. The double angle is sine of 2, that the big 2 here, is 2 times the sine of x cosine of x. It does not equal what we see over here. So be careful, I have seen that mistake made. Sine squared and sine 2 of x are not the same thing. All right, so let's go to our first example. What we give you is a right triangle in this picture. And we want you to find the sine, cosine, tangent, and sum of the double angles using our formulas. So let's go ahead and identify the hypotenuse. We need the hypotenuse to find the main trig function, sine, cosine, tangent, cosecant, secant, and cotangent. So I'm going to identify this angle, x. This is my side adjacent. This is my side opposite. This is my side hypotenuse. So let's find the hypotenuse first using our Pythagorean theorem. A squared plus b squared equals r squared. It's a very popular equation you've used in other videos. So our x and y, so x squared. All right, so we get 1 plus 25, r equals the square root of 26, or hypotenuse. Now let's go ahead and find the sine of this triangle. Remember, in right triangle trig, the sine represents, so opposite over the hypotenuse. So opposite is 1, the hypotenuse is square root of 26. We can't leave the answer like that, so we have to rationalize it. So I'm going to multiply the numerator and the denominator by the square root of 26. Now we multiply across, we get the square root of 26 over 26. Now let's find the tangent. The tangent is opposite over adjacent, so we get 1 over 5. So we've already learned how to do that already. Let's find one more here. We'll just call this C. The cosine of x is ca adjacent over the hypotenuse. So your adjacent is 5, your hypotenuse is square root of 26. Rationalize it. You get 5 square roots of 26 over 26. So those are the big 3, sine, cosine, and tangent. Now let's do the double angles. So I have the formulas here in the green. And we want to find the sine of 2x. So I'm going to refer to my formula. The sine of 2a is 2 times the sine of a times the cosine of a. 2 times the sine of x times the cosine of x. Now we're going to go ahead and substitute those numbers in from what we found in part A, B, and C above. So 2, here is your sine of x. So square root of 26 over 26. And then here is your cosine of x, which is 5 square roots of 26 over 26. Now we'll multiply across. 2 times 5 is 10. The square root of 26 times the square root of 26 is 26. I'm going to leave those two 26 alone for a minute. And the nice thing about that is one of those 26 cancel. 10 over 26 reduces by half to 5/13. So the sine of 2x for that triangle is 5/13. Now let's find the cosine of 2x. The nice thing about the cosine of 2x is you get 3 different choices to work with. You can choose this first one, second one, or third formula. It doesn't matter, you'll get the same answer no matter what. So I'm going to go ahead and just choose the third one. So 2 cosine squared of x minus 1. So I get 2, and I have to go up to my cosine of x. Here's my cosine of x, 5 squared to 26 over 26. And I have to square that because it says cosine squared of x, and then minus 1. Now let's go ahead and simplify that. So 2, we're going to go 5 squared to 26 over 26, and you're going to multiply it to itself again. 5 times the square root of 26 over 26, and then minus 1. Multiply across, 2 times 5 is 50. The square root of 26 times the square root of 26 is 26. And then we have 1 times 26 times 26, and then minus 1. The 26's here will cancel. So we have 50 over 26 minus 1. I'm going to go ahead and change that 1 to 26 over 26. 50 minus 26 is 24 over 26. Then you can reduce it by half. So you get 12/13 as your answer. Now, if we ask you for the double angle for the inverse functions, notice over here on your formula sheet, it only has the big 3 double angles, sine of 2a, cosine of 2a, and tangent of 2a. And this question is asking for the secant of 2x. So remember your reciprocal functions. Secant is the reciprocal for the cosine. So I'm going to say 1 over the cosine of 2x. Well, here's what I just found right up there. So it's 1 over 12/13. Now we'll just simplify that. 1 over 1. Change it to multiplication and flip it. Multiply across, 13/12. All right, last one. Tangent of 2x. The formula we're going to use, down at the bottom, 2 times the tangent of x over 1 minus tangent squared of x. So let's head up here and find the tangent of x. Right here at 1/5. So we're going to substitute 1/5 in for the tangent of x. 2 times 1/5 all over 1 minus 1/5 squared. Now we simplify that. Multiply across. 2 times 1 is 2/5 all over 1 minus 1/5 times 1/5 is 1/25. I have to clean up that denominator, so I'm going to change that first number of 1 to 25 over 25. So I have like denominators. I get 2/5. 25/25 minus 1/25 is 24/25. Fraction over fraction, 2/5. Change it to multiplication. Now we can reduce these 2 by a 5 and these 2 by a 2. Multiply across, 5/12 is your answer for the tangent of 2x.